Give you quick steps, like I gave you quick graphing. Okay? So the first thing I want you to do when you're looking at these equations, is determine how many things do you see. Remember yesterday we talked about nouns? We talked about nouns, we talked about modifiers, right? How many things do you see written in this sentence? Now, things in an algebra sentence are typically separated by plus signs, minus signs, and equal signs. So maybe that will give you confidence in responding to it. How many things do you see in that equation? Things are separated by plus signs, minus signs, and equal signs. Things we call terms. We call them terms now. Do you see 4? Somebody sees 4? 3. Frankie's got these fingers up. 3. Anybody else see 3 or 4? Come on, commit. 3, 4, 4, 3, 3, 4, 4. Those that have 3 fingers up are correct. Things that are separated by plus signs, minus signs, or equal signs. See, here's a thing. There's no plus sign or minus sign. So this is one thing. Remember yesterday we talked about this being a noun. A what? And what is the number in front of it communicating?
It describes it?
It's a descriptor. It's a
Adjective.
modifier. How many of that thing we have? So how many things is this?
One.
One thing. You just have 4/5 of that one thing. Plus sign, this is a thing. Equal sign, that's a thing. 3 things. Because we had such a mix, about a 50-50, seeing 4 and seeing 3, that's a huge problem. We've got a serious issue now. Maybe I just fixed it. Things or terms are separated by plus signs, minus signs, and equal signs. You need to at first be able to count how many of those things are. Because the first step that I'm giving you today in a quick way of solving these equations, that you're feverishly taking these notes down, because you've never seen them anywhere in the world. You go outside here and you've never seen them again.
Unless you go on YouTube.
Collect like things. But before you can collect them, you have to know how many you got. Alright? So again, we got 3 things. Once you see the 3 things, then you need to be able to determine, of those 3 things, how many of those things are like things. Remember yesterday in our nouns. Do you see this one thing? Is there another thing like it?
No, sir.
No, it's not another accident. Well, look at this 8. Is there another thing like it?
Yeah.
Okay. So the technique that I'm going to show you today has got lots of things. You're going to think, oh, why do I need to do that? One of the things that I'm going to ask you to do is to recognize that the equations that we give you in the world of algebra has 2 parts of the universe. Has a left side of the universe and has a right side. It's separated by the equal sign. So when somebody says the 8 is on the left side of the universe, you know that the 8 is on the left side of the equal sign. They're not on the same side. 20 is on which side of the universe? So as you're going through these processes, which you're going to get faster and faster, you're going to show less and less work because you're going to start doing it in your head. It's going to be that easy. You need to be able to stack, when you start this process, I don't want you writing things on the right-hand side, I don't want you writing things on the left-hand side. I want you to stack the equal sign so that your left and right side of the universe is never confusing. You're never confused where your left and right side is. Because we're going to collect like terms. Are there any like terms on the left side?
Nope.
Then what we have to do is to move like things together. You said which 2 terms are like?
8 and 20.
8 and 20. But they're not on the same side of the universe. So I want you to think about it this way. Now I'm not asking you to every time draw this funny little picture. I'm just trying to give you a word picture to help you understand what quick process we're going to have you go through. So that 8 and the 20 are like terms. Now listen to me. You can move anything, any term, to the other side of the equal sign. You can just move it. Now your Algebra 1 teachers taught you, well, if it's being added on the left, then you need to subtract it to undo it, and that's exactly right. They're absolutely correct. It's just that the method that they gave you is slower, takes more paper, and wouldn't you like to see a process that's just as accurate, but could save you time? Sure. Right? So let me show you this. I can move the 20 over here, but as I'm solving equations, what I'm really trying to do is get this x thing all by itself on one side of the equal sign. So if I move the 20 over there with it, am I helping myself? No, because I'm moving it over there with the x. Really what I want to do is get everything away from it. So I've got three things. I've got this one thing, 8, on the same side of the x. I want to move it, so I packed it up in the moving thing. And in your notes, I want you to write these three things. I'm going to move it over here to this right-hand side of the universe. So the three things I want you to think about is not what your Algebra 1 teachers taught you. You know, Mr. Barber did a great job with what he showed you last week. What I want you to think about is I'm going to move this 8, which is like the 20. I'm going to move it to the other side. Anytime you move things and cross the equator, I went from the left side to the right side. I crossed that equal sign, that equator of the universe. When I cross it, I change the sign. If it's a negative thing on the left and I move it to the right, it becomes a positive thing. If it's positive on the right and I move it to the left, it becomes a negative thing, and so forth. Anytime I move, it changes its sign. And then the third thing I want you to do is always use the adding rule that we learned yesterday. Oh, get that. That's my phone. So you're going to move, you're going to change the sign, and you're always going to use the adding rule. That's what you're going to do. Now, compare that to what your Algebra 1 teacher told you. If 8 was being added, you're going to subtract. Well, if you subtract on the left, what do you got to do on the right? Subtract. And so you would have subtracted 8, drawn a long line. Am I right?
Yeah.
And then add things, subtract things, move things that aren't, and you got one whole page for one problem of paper. Not that it was wrong, but I'm just trying to get you to grow up a little bit, and we're going to do things a little bit quicker. All right? So, I'm going to move it. I'm going to change its sign, and what I recommend until you get used to it, start doing it in your head. The 8 is now negative on the right-hand side, and I'm going to write it right above its like thing. Just going to write it right above it. So now I've got a negative 8 and a positive 20. The 8 isn't there anymore, so I can mark it out. That way I keep track of what I've done. The 8 is not on the left-hand side anymore, it's on the right-hand side, so I mark it out. So what's left on the left-hand side, since the 8's not there anymore? What's on the left side?
4/5 x.
Yeah, very good. 4/5 x. 4/5 times x.
Yeah.
That's what's left on the left because I've moved everything, moved the 8 on the right-hand side. But now I've got a negative 8 and a positive 20, and so we're going to review the adding rule that we learned yesterday. If the signs are the same, you got to add instead. But if the signs are different, you got to subtract.
And keep the sign of the larger
Subtract
x.
what? Subtract what? Give me a number.
8.
20 minus 8. Is that easy for you to do?
Yes.
So once you recognize the signs are different, ignore the signs, just go 20 minus 8, getting. And is it positive or negative? Why?
Because the larger x.
Because you keep the sign of the larger x. The larger number is 20, it's positive. So you just subtract, keep the sign of the larger one, which is positive, and you use the adding rule. You move, you change the signs, and you add. Move, change signs, and add. You move like terms, write it above it, change its sign, and always use the adding rule. Okay? Always use the adding rule. Now, don't let this confuse you. Stevenson, you subtracted. The song even says subtract. And you're saying don't subtract. I'm not saying don't subtract. I'm saying use the adding rule. If the signs are the same, what are you going to do? I'm sorry, if the signs are different, what are you going to do?
Subtract, keep the sign of the larger x.
So just use that adding rule every time you do it. Now, once you get this to this point, here you have a thing. What kind of thing is it? What's the
Variable.
noun?
Variable.
It's an X thing, and you got this many of them. Over here, you just got a number thing, right? No variable. Or actually, there is a variable. It's just we don't write it because we're not hillbillies. What is the variable?
1.
Wrong. Variable. Not a
Oh.
number. I'm going to say you can write the X thing there.
If x equals 1.
What is X to the 0 power?
0. Oh, well, it's self. It's itself.
Anything raised to the 0 power from algebra 1
Is
or
itself
pre-algebra is 1.
Oh yeah.
So what is, this says 12 times
I know
what?
that. Jesus.
So is it still 12? Now, is this thing like this thing?
No.
Why not? They're x's, Stevenson.
Exponents.
They're not like terms.
This is x to the, why aren't they like terms?
Because
what I'm
the
asking.
exponent.
X to the what power? Because we're not hillbillies, we know it's there, we don't write it. But this is x to the 0 power. Those are different things. Right? So we could write that as a variable. But we're not, we're hillbillies. We know that 12 times 1 is what? 12, and we don't have to write that. We can just write it. We've seen that before. Right? So those aren't like terms. So when you get to this point when the things are you have only two things left and they're not like, then you go to the second step. And you either multiply, like you learned back in Algebra 2 or Algebra 1.
Multiple. Multiple.
Multiply. Thank you, Coach. Or divide, depending on what you need to do. So in Algebra 1, they taught you. And when something's being multiplied, what do you do to undo that? How do you undo multiply?
Division.
Divide. And when something's being divided, then what do you do?
Multiply.
You multiply. So look at this problem. And here x is being multiplied by 4. This says 4 times x. You can
4 times
rewrite
x
this
divided by
as
5.
This way. Maybe you see it better that way. This says 4 times x, right? That's the same thing. So so x is being multiplied by 4. Well, what else is happening to x? It's being divided by what? 5. So in this problem, because the way they set it up, we're going to have to do both. Multiply and divide. I'm going to multiply by 5. Why? Why do I multiply by 5?